So number 9, we're going from ethane to ethyne. So alkane to alkyne. Again, not possible to do in one step, but you can see here we haven't added any carbons. So essentially this question is really about how do you turn something that's sp3 hybridized into sp hybridized. So essentially it's how do you add pi bonds to something? And we just talked about, we've learned about, well, the only way to add pi bonds is through elimination reactions. The only way to do elimination reactions is actually to have leaving groups. And we've learned a lot of ways to add bromine. So for this one step back, right, to make an alkyne, we actually need to have 2 bromines. Right? So you need to have 2 leaving groups, right, because you're adding 2 pi bonds. So you'd want to have bromine on 2 spots. And now this should tip you off. If you see 2 bromines, you know ways to add 2 bromines. An addition reaction, one of the first reactions we learned, was actually you can add 2 bromines to an alkene. 1 and 2. And now we have an alkene. Well, how do you... Alkene only has 1 pi bond. So to make an alkene, you need to have 1 leaving group. So that would mean you would have almost a starting material, but with only 1 leaving group, carbon 1, carbon 2, and then going backwards to that final thing. So a lot of this is just about, do you know how to add bromines, and then do you know elimination reactions, a bunch of E2 reactions with really, really reactive things. So the first step going forward is something we've seen before. If you want to add bromine, Br2, and light energy, that adds 1 bromine. If you want to do an elimination of bromine and not an SN2 reaction, because that's still a primary alkyl halide, so we really need a big, bulky base. So that tert butoxide is a good one. So that for sure we'll do an E2. That won't let us do an SN2. That'll get us to an alkene. If you want to add 2 bromines, that's one of the first reactions we learned. Just add Br2, right? And that makes that bromonium ion. Once you have the 2, and of course that's a trans addition, but that doesn't matter here. Once you have those 2 bromines, now you need a really, really strong base. And one of the examples we often use is NaNH2. But just some sort of super reactive base. And why is NH2 minus more reactive than O minus? Well, nitrogen is less electronegative, therefore it'd be more reactive. And that's going to really help us do the double elimination. You'd have to have this in excess as well. They don't actually ask for that in a sapling, but something to think about. So see, the big take-home message, C pi bonds need leaving groups, right? What are the ways to add leaving groups? We've learned Br2 and light is a way to add things to the Markovnikov, the more substituted carbon. Peroxides, HBr and peroxides adds it to the less substituted carbon. That's anti-Markovnikov. If you want to add 2 bromines, use Br2. If you want to add 1 bromine and an H, that's HBr, an acidic condition. So there's lots of ways to do that. So kind of be thinking about those in those elimination reactions.